Welcome back to the video series. This is video 5 in the series, and we're going to talk about the statistical probability of a loss. A very, very important concept, of course. We don't want you to lose any money in this program, and I certainly don't want to lose any of my money in this program. So this is an integral part of the whole program itself. So let's turn to the whiteboard, because there's a number of nuances that go into this calculation, and for those of you that aren't too statistically minded, don't worry, I'll make it easy so you can follow along, and you'll see that the probability of a loss is incredibly small. Right, the first thing we're going to turn to are the students themselves. And I don't know if you can recall from the video number 3 when we went into this in a little bit more detail, but this is the graph of a slow pay. So the students have a slow pay rate. Now, why is it called a slow pay rate rather than a default rate? Of course, a student can't default on his debt. So you have to ultimately pay. There's no way of getting out of this in bankruptcy. So we call it a slow pay rate. And down here we have time in months. Okay, so we have here roughly a 30% slow pay rate, and this would equate to month 1. We take you over to month 12, and this slow pay rate, as you'll see on your screen, we're going to show you the actual payment graph, but remind you once again that the slow pay rate drops like a stone. So by the time you get over to month 12, you have a slow pay rate of less than 4%. Now this is critically important, because remember, when you buy into this loan program, you're not buying in, your investment doesn't come in here and is assumed to lose 28%. There's not that possibility. Why? Because when you invest in this program, you become part of the entire, this is critically important, of the entire loan portfolio. Now this loan portfolio right now is sitting well over $50 million, so let's assume you were to invest $100,000, your $100,000 goes into the pool of the investment. So it's spread amongst all of the notes that are in our portfolio, not just at the beginning of the portfolio. That's the first critical piece, because if you remember in video 3 we discussed that 40% buffer that we have. The 40% buffer is more than covered, because right now, based on the longevity of the portfolio, our average slow pay rate is less than, well, sorry, this actually should be the other way around, less than 10%. If our average is less than 10%, we have a 40% buffer, you're obviously incredibly well covered. But that's just the beginning. Let's turn to the second part of the equation. The second part of the equation is obviously you have a portfolio of student loans. Right? We've already discussed the student loan piece of the portfolio. Attached to that, you have a number of schools. All right, now remember, we have a full recourse from the schools. So any student that becomes a slow payer, we go back to the schools, and the schools refund us our money. Now, why would the school do that? I'll remind you once again. We have the 90-10 rule. 90% of the school's revenue, or up to 90% of the school's revenue, comes from the government. We are the 10%. The school would be really foolish to default on our 10%, jeopardizing their 90% from the government. If they were to jeopardize that 90% and lose it, then yes, the school would be in trouble. So the chances of a default from the schools, or them not standing against their loan guarantee, is minimal. So what were to happen if all the schools said, we're not going to give you any recourse, we're not going to fulfill our obligations? What would happen to the portfolio? Nothing. Why? Because the students continue to pay. The student cannot declare bankruptcy on their loans, they continue to pay, we collect a windfall because we have that 40% buffer. Right. Let's assume all the students, every single one of them, say, you know what, we're going to retire, we're going to revolt, we're going to go and camp out at the New York Stock Exchange, or whatever we're going to do, we're not going to pay. What happens in this portfolio? Nothing. Why? Because the schools step in and refund us all of our money. How then is there a default? And I'm going to go back to the red pen. The only way you can get a default is to put a very big red letters and between the two. You have to have the students defaulting and the school's not paying us. And it's better than that. Why? Because you need more than 70% of the students to stop paying and 70% of the schools to stop paying. Only at that point is there a chance of a default. Why? Because the two funds, of which I have one, step in and refund you your money. So it's actually a higher percentage than that. In fact, it's an even higher percentage when you come back to the fact that you've got a blended student loan portfolio. So what if you take these calculations and statistically mash them together? What is the true statistical probability of a loss? Well, I sent this over to UCSD and I met with a professor over there and he calculated the probability of a loss ever occurring in this portfolio of less than 0.1%. That's about as close to zero as you can get. In fact, he said if we dug deeper, because we did quite a high level calculation, it would actually get lower. So the probability of a loss in this portfolio is as close to zero as anything I've ever seen with a very good rate of return on your cash.